Welcome everyone. Finally, we are back to Norway. This is Hessdalen. Winter's coming. That's what Rune says. He's reported he made this video visual, amazing stuff. The team has been working hard lately. They've been collecting eyewitness reports. It's from first generation. That's John Moen there in the middle. Rune's on the left. So they're working on a new research station. As you see, it all takes time, money, fuel. This is up in the Arctic. I went up there. It was really cold when I went up there back in September now, I believe. So they're going out into the Arctic wonderland up there. I asked what they're doing with the flares. It's really to test their new equipment, research station number 3. So trying to get more power out to the station. These things are out in the middle of these valleys. And so testing also the flares, each one of those is $50 to test it. Burns for 3 minutes, Rune says. So if you imagine the Hessdalen phenomenon, right, burns for hours at a time and no smoke. Man, the valley is amazing. It's so nice being up there in the tundra, reminding me of Alaska. There's Magnus there on the left. That is the Black Lodge. John Moen on the right. Frank there on the left, the pilot. Amazing stuff. I do miss the cold. All right, there is Rune. Okay, he's excited. They are mounting a new effort, new team. So we're talking about Hessdalen. They've had UFO studies there now for almost 40 years. That's a photo of Dr. Alan Hynek when he visited in 1985. He visited Dalen. You see these hardy Norwegians, man, these people just surviving up in the north. That's the Hunter famous story. And you can look in their eyes. You know, Rune's talked to him in person. He doesn't think they're lying. The photo doesn't look like he's lying. So now Team Hessdalen is on its way to the city of Trondheim. They're entering, Rune says, with full force. So they're meeting with a technology company for hopefully a new wave of financing these researchers. You have people dedicated. We have 8 members of the team, is what Rune says, experts from all over the country. They do have people, I believe, also from Sweden. Erling Strand will be there. Rune, Magnus, and some new members that the team has recruited. Rune, he mentioned to me they'd like to thank John Boyer of Lots Farm who came forward, and that's after I visited up at Hessdalen, and he wants to sponsor the infrared camera. So Rune immediately got in touch with John, who follows my channel actually, Lato Files, and he wants to donate a camera to Team Hessdalen in 2024. So thank you so much to John, and yeah, that's through the Lato channel. So the team at Hessdalen want to say thank you very much, send best regards for the support. Rune says, surprisingly, there have been no trolls. Lucky. Amazing. No one was interested in being eaten alive, he says, by either a wolf or Norway's Great Mountains. Although, I will say to Rune, we did have volunteers for sure. There were people that did volunteer that would come. They weren't trolls, they said, but they would volunteer. Okay, the team also reports, and this is new updates, okay, coming. So there is an update about the dive operation. So there will be a closer collaboration in 2024 with UFO Sweden. UFO Sweden, that's with Klaus Svahn. I interviewed him as well. Is often referred to as the world's best UFO organization. So they have big plans for 2024, talking about ghost rockets. Ghost rocket is what they are looking for. Rune and Magnus going back to Lake Gypsjøen. The final hunt, Rune calls it, the hunt for the ghost rocket, which he has named Operation Arctic Seals. Operation Arctic Seals, I think, is because they're planning to go under the ice. So they will use ice, cut it up with chainsaws and go ice fishing, essentially. Set up one of those little huts and go down with pumps and divers into the icy water. This is planned for February, which is also the coldest month in Norway, unfortunately. The company, so Fosen Subsea is the company. They're from the island that Rune is also from. So Rune, using his charismatic personality to make things happen. I would love to go out February. I've been traveling a lot, but to be honest, it is tough to fund it. It's much cheaper just staying at my house and making videos rather than going out in the freezing cold. But I will go if, the community really wants it to happen and is worth me spending the funds. I put everything basically from the channel back into the channel. So if it's worth it, then I would love to go. Hopefully we have some new patrons that can help out with that. Otherwise, man, either way, we're definitely going to see what's going on, and they're going to send people to the bottom of that lake. Amazing stuff. So when Vikings start hunting for UFOs, there may be hope. That's from Runa. But it's not only Vikings who are interested in Hessdalen, not only Norwegians, okay? Project Hessdalen has an amazing member, astrophysicist Massimo. Massimo is well known around the world for all the different organizations he's a part of. Even though he's an Italian, he has been working in Project Hessdalen for many years. And now I have an interview exclusively with Massimo. Thank you so much for being here. Let's get to the interview. Chris Lato, welcome to Lato Files. Okay, welcome to Lato Files. I'm very excited today to finally talk to an experienced astrophysicist who has been looking into the UAP phenomena for decades now, for many years, and that is Italian researcher Massimo Teodorani. He's an astrophysicist from North Italy. His PhD is in astronomy from Bologna University with a specialization in stellar physics, and he has been, from my understanding, the lead scientist at Project Hessdalen for several years now. So very happy to bring on Massimo. Hello, Massimo. Thank you for being here. How are you doing?
I'm well. Thank you for having me here. It's very important that science is considered because it's the key point of our research here. There is no other way.
Excellent. We were discussing just before we went live there and looking back through the many papers that you've written. And it seems like your goal or your angle is really the skeptical scientific viewpoint. Is that correct?
Not exactly. I would say it depends on what you mean for the term skeptical, because healthily skeptical is what is demanded by science. But when you say you skeptical by as a belief system, no, that is not scientific. So I don't have that specific belief system, but I believe that we have to cut hair into 4 parts before telling what we want to tell. So we have to distinguish very well the signal from the noise. And the best way to understand the signal is to elaborate meticulously every source of noise. In any fact, I am open to the possibility that Earth is might be visited, because nothing in science prevented this possibility, even if it's quite remote. But we have to understand several facts that we have to measure. We have to calibrate well our instruments. We have to obtain very precise measurements before telling something, because we cannot mock ourselves. We cannot make a fun of ourselves. We cannot make a fun of the other people. So we have to try to take measurements that are rigorous, and to try to see what the numbers are coming out are telling us, so that we can build possibly some physical information. Anyway, I can anticipate that it's not an easy task, because it's not like pointing stars in the sky. We already know the coordinates, okay, then so it's automatic to find the star or the galaxy we want to measure, because we have the coordinate, and so we can take all the measures we want. In this case, the phenomenon is erratic. It's not predictable, okay. The best way to do this kind of observations is to go to some places like Hessdalen in Norway, for instance, but it's not the only one, where the phenomenon occurs very often. And at the same time, use automatic station, that measurement stations, composed of different instruments, and hopefully that they can take data. In the long run, they can take data. So we have already done several missions in Hessdalen. I went there 4 times, but also to the Arizona desert, to Canada, to Ireland, and several places in Italy, just to to make a field work. Okay, we now wanted to do something more sophisticated, and equipment that we are going to implement in Stalin, for instance, of which I am a scientific advisor, is a system that is very similar to an optoelectronic system that is used by the military, for instance, when you have a counter-air system. So you have infrared, you have video camera, you have pan tilt zoom cameras, in order to track the object, to zoom on it, and then instead of using missiles or 20 millimeter cannon, of course, because we don't want to shoot them down, we would use instead sensors like infrared camera, all sky camera, just to see if there is something strange in the sky. There is a camera that is already instructed by artificial intelligence to eliminate, to avoid any kind of known things that man-made, natural or something. And then when we identify something that is anomalous, the information is given to a pan tilt zoom camera that will zoom on the object and will be able to take images at the highest possible resolution. Images is one thing, but it's not sufficient if you want to make some physics on the phenomenon. So we need an additional analytical, 2 analytical instruments. One is a spectrograph, which is able to analyze the atomic state of a luminous phenomenon, because we aim at luminous phenomena in the night. So taking spectra, you can identify chemical elements, the temperature, the pressure of the gas that are producing this phenomenon. And sometimes, if you use enough resolution in spectroscopy, you could also measure a particular effect on the spectral lines if they're present in the continuum, an effect which is called the Zeeman effect. Zeeman effect is a splitting of spectral lines in 2 or more components, and the distance between the 2 components would give directly the strength of the magnetic field.
Okay.
So we clear, the more the resolution is high, and the longest is the exposure time that we need to take a photograph of the spectrum. Okay, but I have been reading a lot about UFO literature, and being patient, sometimes it's possible to find nudges between the stones. And there are indeed nudges, namely some previous measurements that were listed by, for instance, by article by physicist Bruce Maccabee, by astronomer and computer scientist Jacques Vallée, which showed that this phenomenon can be at times extremely luminous. So this means that given its luminosity, the exposure times that we can use both for images and for spectra can be relatively short, in the sense that not only we would take one frame, but more frames one after the other, so that we would study not only the structure of the phenomenon spectroscopical or photometrically, but also possible variation of its physical parameters. And this is exactly what we do in astrophysics when we want to understand the physical mechanism of objects that we are studying, like quasars, like pulsating stars, like black hole candidates or something like that. We want to apply the same technique to the study of these lights, because we are dealing with photons. Okay, so the physics is exactly the same. Consider that I mentioned spectrograph, I mentioned imaging, but you have to consider that at the same time in which these optical measurements are taken, we wanted to use other instruments that are in different wavelength, like a radio spectrum analyzer, possibly from the very short wavelength microwaves typically, or in the very long wavelength like VLF. So that one, a magnetometer, an infrared FLIR, forward-looking infrared, in order to scan the sky, just to see the thermal track that the object lives in the sky. And it's very important, because I remember when I was in Hessdalen, all of a sudden there was one of these light phenomena over a lake, Oyungen Lake, close to Hessdalen. All of a sudden disappeared. But I had night goggles and I could see it. It was still there. Okay, only it disappeared from the optical. So we have to use simultaneously instruments that work in different wavelengths, more typically optical and radio. Okay, possibly also the ultraviolet, and also looking if there are some high energy particles like muons, like those of cosmic rays, that are emitted by the phenomenon. From the optical spectrum and also from the radio spectrum, we can understand if the phenomenon is thermal or non-thermal. This we find in astrophysics, in astrophysical objects. And if the spectrum, if the slope of the continuum is in one direction instead of the other direction, the spectrum, the object is not thermal, is not produced by ionization, but the light is produced by a very strong magnetic field that is accelerating relativistic particles. So we can understand something, okay, matching this with the characteristics of spectral lines. We can understand possibly the physical mechanism of the object, looking not only static images, but also the way in which it changes with time. And in case we could deduce also the effect of a possible propulsion mechanism. Okay, if you have, for instance, a flying machine that is propelled by, for some reason, by a very strong magnetic field, which is produced by huge electrical fields flowing into a superconducting device, otherwise it would explode, then we can deduce it from our data, looking at the data all together, assuming that data are taken simultaneously and automatically. So this is physics applied to this phenomenon. And if we are visited, we should understand that, unless they have cloaking device that we want to hide them from us.
Okay, well, thank you, Massimo. I mean, amazing already so far. I think there was a lot of detail in there. My first point is there's this idea in the UAP community that there's no peer-reviewed research papers written about UAPs. But like, if we look here, this is literally your research paper.
It is peer-reviewed, yes.
Yeah, peer-reviewed from 2000. So you have written, sounds like many scientific articles, 18 books, etc. Have you written a lot of peer-reviewed articles that have been peer-reviewed, scientific?
Yes, absolutely, yes. Well, apart
Okay.
from the astrophysics articles, which are most of them are peer-reviewed, also articles regarding these specific subjects.
Hmm.
I have several peer-review
Ah,
articles. And, the last one is on the a new journal, academic journal, the Journal of UAP Studies, called also Limina. But I have peer-reviewed article on Acta Astronautica,
ah,
on the Springer editor of books about astrobiology, and several others. So
yeah.
I have peer review article. Also, the Journal of Scientific Exploration is peer reviewed. I try to to submit my ideas under the torture, of the reviewers, which is a role that we subject to ourselves to try to check our mistakes, to improve our work. And with this subject, it's very delicate. Okay, so yes, I published several peer review articles. Yes.
In the community, we're under the impression, at least I was, that there's no peer-reviewed scientific papers here, but I'm looking at one that you wrote: physical data acquisition and analysis of possible flying extraterrestrial probes by using optoelectronic devices. So this is back from 2000.
Yes.
And I noticed here you relate luminous events, and you mentioned they're trying to get another spectrum of viewpoint, another observation in a different spectrum. Obviously, we want many different viewpoints of the same event. And here you have luminous events, so optical, and then you have magnetic events, which is
Yeah.
in the
Yes.
magnetic spectrum. And yeah, this seems very interesting to me because obviously the electromagnetic spectrum has a relationship, as you know better than probably any of us, is you have the electrospectrum and then you have the magnetic spectrum. So it seems like if we are picking up luminous events in Hessdalen, like these lights, that we should also be able to pick up the magnetic events as well. So if there is a light event, right, and correct me if I'm wrong, shouldn't there be some sort of magnetic anomaly if we see some light anomaly? Is that the assumption that you're making or we're making?
Yes, the graphs that you have shown before of my paper
Hmm.
are my simple analysis of data that were taken in Stalin by Erling Strand, professor of engineering, and this group of Project Hessdalen. They looked, they observed at the same time a luminous phenomenon and strong magnetic pulsating events. Okay,
Hmm.
so this is only symptomatic, but we don't have yet a very detailed description of that. Uh, the best way to measure the magnetic field, as I anticipated before, is through optical spectroscopy, because if we have
Hmm.
this splitting of spectral lines, if there are spectral lines, then from the splitting we can measure the magnetic field of
Excellent.
the plasma that surrounds the object. Okay, at zero distance, at that distance. If we use a magnetometer, the way in which the magnetic field intensity decreases with the distance is inversely proportional
Hmm.
to the cube of distance. So if
Hmm.
you have a strong magnetic object that is 2-3 kilometers away, we might not see any magnetic event because it
And
goes down very quickly. That's the reason why I think that optically, spectroscopically, if we are lucky, we could measure the magnetic field independently from distance and intrinsically to the plasma that is inside this magnetic cage. What is important is to try to establish a correlation, so to see if the physical parameters that are taken in different wavelength are correlated together. For instance, if you have an abrupt change of luminous intensity, or change of color from red to blue, for instance, what do we observe in the magnetic field? Does the magnetic field increase, Or if the light is pulsating, is also the magnetic field pulsating? Is there a correlation between these electromagnetic characteristics and what we see in the light? Because if we put all these things together, we build a lot of charts. At some point, we can build up the equations that describe those charts. And from that, from the experimentation, from the observation, we can deduce a mathematical physical theory that is able to fit the data in the best way as possible. At that point, we would have a true theory, okay, because it's based on the data and it is quantitative, okay. So I stress the importance of trying to understand the propulsion mechanism of these things, or if it is a natural phenomenon, the physical mechanism of the phenomenon per se, because it's also important, because if we understand the way in which such phenomena behave and the reason why these lights are so self-contained and last so long time, up to 2 hours, if we understand that physics, we could build reproduce the same phenomenon in a laboratory, and after that, in case, we could use it as an energy source. I can tell you that the magnetic field that is predicted by natural phenomena like ball lightning cannot reach, according to literature, theoretical literature, 1,000th of 1 Tesla, okay? Instead, if we see something that is a factor 1,000 more, like 1 Tesla, 10 Tesla, 100 Tesla, that cannot be natural. And so we can measure that and make physics, because this is probably the last frontier of physics. It's very stimulating. It must be very stimulating, and clearly we need a good dose of how to say, skepticism, but not denying, because we are not religious. We are not following a belief system. We simply want to try to have accurate data and correct ourselves from possible mistakes.
Excellent. You mentioned the article here, investigating UAP events using astronomical techniques. So this is another peer-reviewed study from
the last one. Yeah, it's
yes.
going in press right now.
Okay, excellent. And in this, you highlight what you talked about there as methods, right? We talked through these are the
Yes.
locations. So if people have more interest, they can go to this actual paper. Link will be in the description, and you
Yes.
describe basically thing we've already mentioned: binary stars, pulsating stars, so supernovas, quasars. Also, how to observe them scientifically. I also like this one. This is your next observational steps in the research. You kind of mentioned there. I like the way you said it, Massimo. As you were saying, you know, we're not religious dogma. We're not just going to deny it. Is to actually go and get the actual scientific research. So here you describe how you could go and get the scientific research. What are the plans now? You kind of mentioned it. What is the basic plan for Hessdalen to get these to get this data?
Yes. So no, the idea is a so-called incremental plan that it's an idea, and it's not necessary that we will do so strictly this, but the concept is very close to the reality. A new observatory plan is intended in 3 phases, in my view. In phase 1, we would have first an electromagnetic surveillance system, which monitors in the VLF, for instance, very long wavelength, with a then magnetometer, a radar, okay, and then we would have an optical or a surveillance system with an all sky camera, okay, that is monitoring all the sky, and which is controlled by artificial intelligence that exclude phenomena that we already know, man-made or natural phenomena. We need more than one of these cameras, because then this would allow us to triangulate and calculate the distance of the phenomenon. Because without knowing the distance, we cannot evaluate the intrinsic physical parameters like luminosity, for instance. We need the distance, because the luminosity decreases with the inverse of the square of the distance. Okay, so we need to know the distance through triangulation. Then we would have this, if we identify something in the sky that is anomalous, the command would be given to a zoom camera, a pan tilt system that guides to the target and track it in a reasonably high definition. And then we go to phase two. If we are able to do this, if the pan tilt system works very well, then we know that we can go more deep. And so in phase two, we would replace, not replace, but we would add the zoom camera to a high speed camera, okay, and a medium resolution spectrograph. So we go more analytical, okay. I already spoke about medium resolution spectrograph, because this can allow us to go to see also magnetic effect, like the Zeeman effect. But
and can I stop? Can I
yes,
just stop you
yes,
right here, Massimo? Can you explain?
absolutely.
Because this seems like very effective, right? Because from what I understand is, so the optical, when you actually see light or radar energy, it decreases at the square.
With the inverse of the square of the distance.
Inverse square, right? So as we get further away from an object, the energy, at least optical energy, the way I understand it, it decreases by the inverse square. So it decreases quickly at a square root.
Absolutely.
But the actual magnetic field decreases as the cube.
Yes, exactly.
Right. So
if it is a dipole, yes.
So what I'm understanding here is you're able to, or your idea is to get the distance by measuring the optical Zeeman line, which will tell you the magnetic strength, and then the observed magnetic strength, and then use an experimental magnetometer to tell the difference, and that'll give you the distance. Is that how that works?
Not exactly, but we would use an all-sky camera in not only one, but at least two. When we put the two all-sky camera in at a distance of 1 kilometer from each other, then we can triangulate and deduce the distance of the object.
Yes.
That would be the main system. But we can also use a radar to obtain the distance in case. But this one would be simple. After doing that, we have the distance, okay, at any instant. At that point, whatever we measure with the other instruments, like a high-speed camera, a spectrograph, would be related to that evaluation of the distance, okay? So we would know the intrinsic value of the measured physical parameters, okay? So this is extremely important. In particular, I didn't speak about the high-speed camera. High-speed camera is something that is able potentially to measure 1/1,000,000th of second frames. Incredible, but it's not convenient, because the more the time resolution is high, and the smaller is the spatial resolution of the obtained frame. So we have to make a compromise, and the ideal would be 5,000 frames per second. Okay, why is this important? Because of two reasons. So this is just a camera, not a spectrograph. It's something that is parallel with the spectrograph. It's important to have a high-speed camera, because if we apply it to a zoom lens and we use it in a wide field mode, we can record in the sky very fast movements. Okay, really very fast movements that normally we wouldn't be able to detect. Okay. Or if we zoom on the object, then we could detect fast variations in the intensity of the light and in the color, which would be a fundamental information for the physics of the phenomenon, because the dynamics could be in a very high resolution, high time resolution. We could go more deep. Okay, we could find something, a period, then we can analyze with the time series analysis all the periodicities. Okay, for instance, it could at some point it could pulsate, and then the rate of pulsation could increase. At the same time, the speed would increase and the luminosity would pass from red to blue. Okay, this is just a scenario. So we try to imagine scenario. We try to put ourselves questions, all the possible questions, and see how can we answer to these questions. Okay, so this is so in phase 2, we see we had this high-speed camera and a medium resolution spectrograph. And in phase 3, in case we would have a FLIR 360-degree or in zoom mode, plus other instruments like microwave, VHF, UHF spectrum analyzer, a particle detector, a microphone that is able to detect also infrasound and ultrasounds. We would use a drone equipped with optical camera and infrared camera, and in case also a LiDAR to scan the terrain to see if there are things of interest there, and also a laser, because a laser could be used to stimulate the phenomenon. For instance, if the phenomenon, one of the effects of the propulsion is to warp space-time, we already know from general relativity that there would be very special effects. A laser beam might be deviated, curved, it could be curved, and the stars in the sky could be displaced. It's an optical, like a refraction, a relativistic refraction, and amplified. This can be documented by the normal zoom camera, and from what we can document, we do calculations on the frames and then deduce the gravitational field of the phenomenon. So there are many measurements that we can do. Something like this is attempted also by the group of the Skinwalker Ranch in Utah, and they are doing a very nice work, and they use very different instruments on demand according to what they want to measure. So this is what we would like to do in Hessdalen if we have money funding. Clearly, we already know what we are able to do. We already know everything in advance. And this comes also from calculations, because you have also to calculate, which I did in the appendix of the paper that you have shown before. You can calculate, you can decide which signals to noise ratio do we want. Ideally would be 100, but if we have 30, 20 would be sufficient. If we assume that we want that signals to noise ratio, and if we want to see a phenomenon that is very luminous or weakly luminous, how long exposure time we would have to use? So we anticipate before what would be obtained if we wanted to obtain a good quality of the data. And so we decide if some measurements are possible or not. So we are already ready with calculations that have been done already.
Okay. What do you hope to find from your next phase at Hessdalen?
Well, I hope to find first, I like the idea to see spectral lines in the spectrum, because sometimes the spectrum doesn't show spectral lines, it shows only a continuum, okay, which can be useful as well. But if there are spectral lines that are produced by particular condition of excitation of atmospheric air, then if I see the Zeeman effect, the splitting of these lines, I can measure the magnetic field intensity. And if the phenomenon is luminous enough, we can take several of these medium resolution spectra in sequence, one after the other. And if we have enough number, we could deduce how it changes, okay? I don't expect it's constant, because I expect that magnetic field intensity varies with luminosity and with color and with speed, okay? So assuming that at the same time we are measuring all the other parameters simultaneously, then we can calculate and we can make correlations and deduce the physical mechanism, possibly. It will be difficult, but it's absolutely worth. It's a fundamental part of the human physics.
How expensive are spectrographs? Are these expensive devices, or?
Some yes, some yes. The most simple is a low resolution spectrograph, and we're using with I would say between $300 and $500 you can buy that. If you want a high resolution spectrograph, then, well, could be $200,000. It's very heavy, but anyway, you can connect it to the optical system using fiber optics, so no problem. And the ideal compromise would be a medium resolution spectrograph without a slit for the dispersion, with slitless, so you are able to track an object without any need to keep the slit, the object on the slit of the spectrograph. Without a slit, you can track the object quite easily, quite well. And so in the case of medium resolution spectrograph, the price is about not more than 2,000, 3,000. And I have a prototype of that, which I have tested in the past years. And yes, we need, if we want to have a complete system like this, I expect we should have at least $500,000, maybe 1 million.
Wow, amazing. And then you mentioned before, and you have done a lot of research in looking into the cosmos. I've also talked to people looking in Hessdalen. They need their images, their sensors to pick up objects that are, a few hundred meters away, maybe a kilometer. Do you find there's a conflict between trying to use systems that can look all the way into space and also use those same systems to try and find phenomena or objects, get data from close objects? It seems like maybe we may need to look two different areas. You have SETI, or deep field cosmology, and then you have sensors that you only need to pick up near Hessdalen, for instance. Like in Hessdalen, you don't need to necessarily, like Sky 360, for instance, all of their systems are dedicated to see the ISS, right? To resolve the ISS. So that's what they need, that level of clarity. But for Hessdalen, for instance, you don't need to see hundreds of kilometers normally.
No.
What is your take on this? Do you think there's any conflict between having sensors that can see very far, or do you get a lot of excess bleed through from the atmosphere, from the cosmos? Is there any benefit to maybe lowering our scope, make the distance that you're gaining data from Hessdalen only a few kilometers, for instance, so that you weed out that signal to noise ratio? Is there any benefit or conflict?
Well, you have to, the point is that the distance is a fundamental phenomenon, because if we have objects that are very close, but they're also very weakly luminous, it's not convenient that we use, not very sensitive instruments. We need to use anyway very sensitive instruments, even if the phenomenon is very close, because will be the received luminosity at our distance would be very high, and this would allow us to obtain spectra, for instance, or image frames in a very short exposure time. If the exposure time is very short, then we can take one after the other, maybe 100 frames of the same object that is relatively close. And in Hessdalen, the radius of the the distance of the phenomenon is around between 5 and 6 kilometers. I calculated in the past. So we have to concentrate on that. We have, regarding the other electromagnetic instruments, like VLF, for instance, in that case, I don't think that we need a very powerful antenna, because the powerful antenna will catch also phenomena that are very far away, like submarine communication that we don't need, that they pollute our data. So we need something that is relatively short range. But for the optical, I would use a maximum sensitivity.
Okay, excellent. That does help. This is the second time I've actually had a astrophysicist on the show, and I wanted to get your question. This a little bit off the topic, but what is your take on the James Webb Space Telescope and seeing all of these galaxies, basically fully formed galaxies, before basically so soon near to the alleged Big Bang? What is your take on that? Do you think there is a crisis in cosmology going on now? Do you think our understanding of the cosmos could be incorrect or could be changing?
It could be changing because James Webb Telescope has a capability of resolution that is, I think, 10 times more than Hubble Space Telescope, and it could shed light on several aspects. For instance, with the James Webb telescope, it's possible to see star formation in a much better way in galaxies. Inside galaxies, you can see star forming regions very clearly, which before it was not absolutely possible. So we would know how stars are forming. Okay, not only, but also brown dwarf can be seen much better and counted inside the galaxy. So statistical distribution of dark stars could be improve our own knowledge of the formation of the galaxy. Going much forward to high redshifts, okay, 10Z, for instance, that will help to understand more if Big Bang theory is correct, or if there's faults, or if there are anisotropies in the microwave background radiation, and how this anisotropy is correlated with the formation of the first stars in the universe. And this we will be able to see that, because this telescope is much more sensitive than the other one. So I think we will have many surprises.
And you mentioned a few of your papers are written on SETI, the search for extraterrestrial intelligence, which is primarily, from my understanding, has been just looking at radio waves from space. You mentioned in a few of your papers an interesting concept of migration. Can you explain just this, what you could possibly be finding through this this migration?
Yes, there are two ways. One, SETI project is mainly based on radio waves, okay, in order to search for signals that are affected by the Doppler effect, because they are coming, presumably, from a planet that is rotating and revolving around their star. So signals that have particular characteristics, narrow band, polarized, or something. And I've been working on that at a radio telescope. We had the Serendip 4 system. We never found anything. Okay. Then there is the optical SETI that is presumably caused by the outshining of a star by the beam of a laser, super powerful laser, that is momentarily aimed at us. That would create a momentary outshining of the star, and we think that laser is another way to communicate. Okay, this is not enough. The point is that, as I proposed to a SETI Congress, we have first to identify techno-signature in space. So there are some expected signatures that we already know what we would find around some stars. First of all, there would be some stars that are of the solar type, from which we do not expect any ejection of shells, of muscles, of anything, because they are stable stars hydrostatically. If we see the effect of this ejection of material through in form of infrared excess, then we would be obliged to think that this infrared excess is due to engineering of around that star, with many artificial objects around that absorbs the light and re-radiate in the infrared. So we would expect an infrared excess from this particular star. So we would find that, which would be a technosignature. Another technosignature would be to have the light curve of objects that are eclipsing the stars, that are anomalous. We already know, for instance, what happens when a planet is eclipsing its star. It would diminish the light of the star in a way that we already know how. But if the object is geometric, it's like triangular, it's cylindrical, something, the shape of the light curve would have a very particular characteristics that has already been mathematically modeled. So we already know what to expect from that. Now, imagine a star, solar type star, okay, that is surrounded by a swarm of many planetoid, even big like the moon, okay. From higher level civilization, we expect something like that, okay. Imagine that you have all these planetoid, and imagine that at some point, for some reason, some planetoids are not anymore revolving around their star, but they are put in motion towards us to explore, or maybe because there is a problem in their star or something. Imagine that one of these planetoid, after 1,000 years, reach our solar system. In this case, we would have signatures, like also in this case an infrared excess, which would be caused not by what was caused before when they were near the star, but because the machinery that is aboard, okay. So we would expect to have this infrared excess, and we'd expect objects that are flying very fast, much faster than the stars that are far away. If they go very fast, this means only one thing, that are flying inside our solar system, because they are very close. Okay, so we could track these objects in the same way in which we track comets. We take at least 2 points of the orbit, then if the orbit is constant, then we can track it, and we can go in depth using super big telescopes like the VLT, for instance, in Chile, or the extra large telescope that is in construction now, to obtain spectra and every kind of information. This is what we should have done with Oumuamua, that Avi Loeb, Professor Avi Loeb, has been studying. And this is a way to see if there is someone that is inside our solar system. In the past, there were several infrared telescopes like Spitzer, like IRAS, that were observing the sky, but they were not aimed at searching this kind of thing, interstellar things. Now we should make a key project that is going directly there. Then, if something is in the solar system, no one prevent us to think that these artificial planetoid behave like carriers, like Gerald Ford carrier that is launching his airplane in exploration of our planet and also other planets.
Is there any way to go and look at past evidence, or past data to try and pick up these objects? Is there any way to look in past databases?
Yes, it has been done by an American institute using IRAS database. IRAS was in the 70s by an infrared space telescope, infrared, and they monitored something like 17,000 objects, from which they found at least 15 suspect sources with an infrared excess. But nothing is definitive. It was not a key project, but something was found that is suspect, and I hope that someone aims the Webb Space Telescope against them to go in depth, because the Webb telescope is also powerful in the infrared, not only in the optical.
Oh, excellent. So it sounds like, Massimo, what I've really learned from talking with you is about the spectrograph and the different levels of reality, the different levels of data that we can gain. And so just so I understand, when you talk about infrared excess, it's kind of similar to the spectrograph kind of analysis, right? Is you're expecting that the optical light from these objects will act differently than the infrared light. So if we can compare the optical light to the infrared light, and we see that there is much more infrared light, which would be an excess of infrared than what we're normally expecting from other astronomical objects, then this would be a suspect in your analysis.
Exactly.
So that could be one of these sort of giveaways, I guess, evidence for it's a techno-signature, essentially. Is that correct?
Exactly.
Oh, perfect. Okay, and that seems to go as well. You're trying to bring that mentality, from what I understand, to Hessdalen here, to try and just get a higher data. So this is from your briefing. We'll kind of just finish on this part here, where you go through empirical deductions on Hessdalen-like light phenomena, and this is from your paper in 2004. I guess I'd like to just go through this really quickly. If you can just list through, like, has any of these changed since 2004, or is this the same? Can you just go through each one of these points? We'll keep this as the last slide, essentially.
It's only the same. The phenomenon is very frequent. It was one of the most frequent in the world. Okay, the phenomenon didn't change shape. The point is that you have three kind of phenomena, two of which are related together. The first one is light balls, so no structure. Okay, like light balls, similar like big ball lightnings that are much longer lasting, of several colors. Okay, sometimes they fly together, they float for a long time. They are often blinking with a period of a few seconds. Okay, and these phenomena, it seems, and Erling Strand knows much more than I do from what they have been observing in Norway, but I also went to Norway, I also saw them. There is sometimes flashes in the sky, sudden flashes in the sky, which look like to be the seeds of what will happen later. Something like very luminous light balls, which sometimes something like 20 kilowatt, which I measured in 2004, but sometimes they can be also much more, like 1 megawatt of power. You have these things, okay? But people, including me, have seen also structured objects in the area. UFOs at all effects, and there are many witnesses in the valley. We don't know how or if the light balls, which look like a natural phenomenon, how or if it is related to the structured balls or not. We don't know that. And it might be that some light balls in reality are structured objects that are completely wrapped by incandescent plasma and make them appear like incorporeal things, which is not. Maybe this is a ionizing effect of their propulsion mechanism. In other cases, it's apparently like ball lightning thing that are there. What is the relation between the two? We don't know yet. I have a funny idea, is that someone might like to stay in Stalin, someone coming from outer space, and they like Stalin and the other place of Earth because there is a lot of energy to suck in. Maybe their propulsion mechanism is like an accumulator, like a dynamo, okay? And the energy that is geophysical. Because I prepared in my lectures, out of 15 theories, I can tell you, 14 are all natural. And there are several theories that predict a way in which these light balls can be formed by piezoelectricity in tectonic areas, like fault lines, for instance, but also by other factors. This could happen also in Hessdalen. Piezoelectric effect could inject voltage in the atmosphere and then ionize the air. But what we don't know, the mystery here, is why these light bulbs are so self-contained for so long time. When you have ionization of the atmosphere, this light would last not more than few seconds, not hours. So we don't know what is the confining mechanism. I prepared some models about that that involve strong magnetic field. So I've been thinking about natural phenomena and non-natural phenomena, trying to consider all the possible scenarios and see then what the data show us.
Do we have any, or do you guys have any magnetic data experiments? Have you received any magnetic signals?
Yes, especially Erlingstrand in 1994. If you go to the Project Hessdalen website, and you will see Project Hessdalen 1994 final report, it shows that they've been using a flux gate magnetometer, which showed the presence of a sort of pulsating magnetic field. I don't remember how many nanotesla. It was something between around 100 nanotesla. I don't remember exactly. But yes, they measure magnetic fields often at the same time in which light phenomena were seen.
Wow, very interesting. And I remember reading through your paper, I noticed that our normal balls of light, so when you say the natural phenomena that is a ball of light, it's none of them have been measured to have any noticeable magnetic field. Right? From what I understand, your magnetic fields from balls of light is very low, whereas from my understanding, we have very high field strengths recorded. Is that correct?
Yeah, it's correct, but there is a reason. The reason is that when these light balls are 1 or 2 kilometers away, if it's a natural phenomenon, you will never measure anything.
Because of the cube root we talked about there,
it goes down. It goes down to the inverse of the power of distance, so it vanishes completely. We cannot measure anything. If you want to measure something magnetically, these lights must be close to you, something like 100 meters, and then yes, you can measure that. And not only, but they can create electromagnetic interference. For instance, there is a big important monograph published by Dr. Rodegier of the QFOS, which published all the effect of electromagnetic interference of this phenomena, that were very, very close, But if they are not close, their magnetic field drops down completely, So it's difficult, but we can extrapolate anyway. If you get something, you know the distance of the phenomenon, then you go through the exponential curve, extrapolate backwards to the source, Or if you are lucky, you use the spectroscopic optical system to see the splitting. In that case, you would have a very precise measurement.
Wow, excellent, Massimo. So it seems like Project Hessdalen is still going very strong. You've gotten a new influx of people and money and energy and motivation. That's amazing. So it seems like now you guys have a lot of data and you're trying to nail in, like you mentioned, what are the lights related to these physical objects that you've seen, that you've personally seen with binoculars, where you've actually seen, it looks like radar signature, magnetic related to very low frequency signatures. So it looks like in Hessdalen, you guys going for phase 1 is going to be the all sky cameras out there, trying to get just optical is what you're focused on initially. And then you're adding in all these other systems, which will be magnetic. You already have VLF, which you mentioned is already out there. There is radar, but the high speed cameras, as well as a more advanced spectrograph, really seem like the kind of breakthrough devices that you're looking to put out there.
Yes.
Is that a pretty good summary?
Yeah. Since the beginning, electromagnetic systems like a radio spectrum analyzer always in function. Okay, we have had the VLF with a powerful antenna, but we want also microwave system that constantly working and recording at the same time in which we get the optical data. So we have simultaneous measurement in more wavelength, which it's exactly what we do when we study important objects like quasars, for instance. We were able to understand that the nucleus of quasars contain mega black holes only because we were able to measure simultaneously in the ultraviolet and the infrared and the optical in the radio. Through this simultaneous measurement, we can understand the physics of the problem. And we can do the same with Hessdalen-like phenomena.
Oh, excellent. Okay, thank you so much, Massimo, for all your time, all your efforts on this. Anyone can go and find Massimo's work. He has, we've already mentioned 18 books, many scientific articles, but I will have links in the description if you want links to the actual briefings that we reference here or any of Massimo's articles. Please go and look into that, research it. One final point here, Massimo. I'm talking with Courtney Brown later this week. He says that he can take a camera, a GH6, a Panasonic Lumix camera, you know, high frame rate, so very high speed, and it's 4K.
Good.
And he takes off the IR filter. There's a company called Pixel-Live, I believe, and they removed the actual IR filter on the camera. Courtney Brown is saying that he, using this high speed infrared kind of poor man's camera, he's able to pick up these really fast moving objects. It almost looks like a dust smear, you know, a dust bunny on the camera, but it's going very fast. So I'll talk with him on Thursday. I'm very
interesting. I'm very interesting, and I want to listen to. Yes.
Okay, excellent. Yeah, that seems like that would be really useful
yes,
for you guys as a possible option. So hopefully that pans out. He has a bunch of videos, and yeah, anyone that's listening now in the audience, look out for that video coming up next. Please follow Massimo, Project Hessdalen, and yeah, you guys are making definite ends, and I hope you all the best. And I wish you all the I wish you all the best of luck in Project Massimo. Thank you, Massimo.
Thank you for having me. Have a nice day. Thank you.
Excellent. Hope you guys enjoyed that interview with Massimo. Very exciting. Project Hessdalen really seems like it has a lot of movement and action going. So this is the actual image from Nordic Subsea. So as promised, they released the image. This is the first time it's being shown. So what you see, that line kind of on the right of the image, that's the boat. The boat is actually going from the bottom to the top. And then it's dragging behind this dolphin, which is basically looking to the side with sonar, right? Side scan, sonar. It has one scanner basically looking to the left. That's that left part of the line that you see. And then it has one scanner looking to the right. And you see that it's basically the land coming up. So the dark part is the water as we're looking. So there's the object coming into view there, as you see. So this is the actual statement from Nordic Subsea. Mainly it was Rock 1 and Rock 2 that is visible in areas with looser masses, but there's also a rash that was detected with sonar that was not visible with the ROV, the remote operated vehicle. We have sent all files for further analysis to be able to decipher it better. There's not one object sticking out of the bottom, rather a signature in the bottom. We'll see if it's possible to get something more out of it. Alternatively, it can be investigated further. One possibility is to go down through the ice with divers, and go down with divers is what we are going to do, as you know. End quote. Strange case, Runa says, but it's the only thing we can do to investigate. So that's what they're planning to go in February. And the idea is they have the exact coordinates, so they can just walk out on the ice, cut a hole, dig a little teepee, and then dive down. Amazing stuff. Thanks to everyone for all your support, to these patreon.com/Chris Lado members, and to YouTube members. If you do sign up, I answer YouTube member comments first, and exclusive videos on both of those platforms. Thanks again for being here. Have a great day. Peace.